Applications of linear functions. So where do we actually use these things? The graph below shows the height of a float plane above a lake as the plane descends to land. So we have the h-axis and the t, and we have height is a function of time. What is the horizontal intercept, the t-intercept? And what does this point represent? So it's 10, and it has units, right? It's 10 minutes. And that is the time it takes. Somehow I opened something I don't want to. It takes for the plane to land. Okay, probably from the time it starts its descent. What is the vertical intercept, the h-intercept? So that's 1,000, and it's meters. All right, this is where, go away. Where are we? 1,000 meters. God, give me back my pen. And that's the height of the plane when it started its descent. State the domain and range of the graph. So the domain is the x values, that's from 0 to 10, and the range, or the x or the t values in this case, and the range is 0 to 1,000. So we're stating the domain. And we can do it in abbreviated notation. So 0 is less than or equal to t is less than or equal to 10, and the range 0 less than or equal to h less than or equal to 1,000. Right, there's a context to this graph, so even if we have an equation that describes it, there's a limit on the domain and the range. What is the rate of change for the graph? So remember that's change in y value. So we can see that this is minus 100 in 1 minute. So it's 100 meters per minute descending, right? So minus 100 meters per minute. And that represents the rate of descent. Determine the equation of the line, express the answer in slope y-intercept form and general form. Well, the y-intercept is 1,000. The slope is minus 100. So h is equal to negative 100t plus 1,000. And that's your slope-intercept form. General form, so remember, we need a positive x. This is our x value. So it'll be 100t, you move that over, plus h minus 1,000 is equal to 0. So a positive, so it's ax plus by plus c is equal to 0, where a, b, and c are integers, and a is positive, right? And a goes with the independent variable. The graph below shows the temperature T measured in degrees Celsius as a function of time measured in hours. What is the horizontal intercept, or the t-intercept? So that's 4 hours. And what does this point represent? The time for the temperature to get to 0 degrees Celsius. What is the vertical intercept, or the t-intercept? That's capital T for temperature. So that is, based on scale, scale's got to be 5s, right? 5, 10, 15, 20, so minus 5. And remember, there's units associated with it, so it's negative 5 degrees Celsius, and that is the temperature at time 0, hours. State the domain and range. Okay, domain, so time goes from 0 to 12. 0 less than or equal to t less than or equal to 12. And the range goes from -5 to +10. -5 less than or equal to capital T less than or equal to 10. What is the rate of change? So at what rate is the temperature changing? Well, we can see that we went plus 5 degrees in 4 hours. So plus 5 degrees C in 4 hours, which we will list just simply as 5/4 for the slope. Okay, we don't want to change that to a unit rate. So 5 degrees Celsius per 4 hours. Okay, so we could say 1.25 degrees C per hour, or 5/4 degrees C per hour. And that represents the change in temperature, the rate of change of temperature. Determine the equation of the line, slope y-intercept form. Okay, so remember, that's y equals mx plus b. So t, that's your capital Y, is equal to 5/4. Don't want to use a decimal, right? Want to use a fraction. 5/4 little t minus 5. That's your y-intercept. To go into general form, we're going to multiply through by 4. 4t is equal to 5 little t minus 20. This is positive, so 5t little t minus 4 big T. Okay, bring that over. Minus 20 is equal to 0, as he runs off the tablet. Sam is driving back to Calgary. His distance from Calgary, d, in kilometers is given by the linear function d is equal to -80t plus 240, where t is the time in hours since Sam started driving. Determine the intercepts of the linear function. So the d-intercept is when t is equal to 0. So d is equal to -80 times 0 plus 240. So d is equal to 240. The t-intercept is when d is equal to 0. That's when we'll be back in Calgary, right? Distance from Calgary. When that distance is 0, then we're in Calgary. 0 is equal to -80t plus 240. Move that over. 80t equals 240. So t is equal to 3 hours and 240 kilometers, right? There are units associated with these. Use the intercepts to sketch the graph of the linear function. Label the axes. So we have a d-intercept of 240. We have a t-intercept here. This is time. And anytime you give time, you got to say what it's in, hours. And this is distance in kilometers. And this whole graph is distance from Calgary. Okay, so we draw that. We have on our intercepts. The only time you really get away with drawing a line with 2 points and, this ends. I really should. I think somewhere there's a straight line tool. Can I use that? Yeah. I think I drew 2 lines because I stopped there, but it's kind of straighter, I guess. Really got to start using that. What does the horizontal intercept, the t-intercept, represent? Okay, so the t-intercept, the t is equal to 3 hours, represents the time it takes to get to Calgary? What does the vertical intercept, the D, so D is equal to 240 kilometers, so the starting distance from Calgary, that's the point at which we started the clock, right? At time 0 hours, we were 240 kilometers from Calgary. Domain and range, all right, what were the variables we were using? D and T, I suppose that makes sense. So the domain, 0 is less than or equal to T is less than or equal to 3. And my range, 0 is less than or equal to D is less than or equal to 240. What is the slope of the line? So down 240 in 3 hours, right? So minus 240 kilometers in 3 hours, which is negative 80 kilometers per hour. So the slope negative, or down 240 kilometers in 3 hours. So if we can, we'll do that as a unit, negative 80 kilometers per hour. In the other one, we couldn't really divide. It's 5 over 4. We just left it that way. Here we can get a unit rate. So the slope represents the speed of the vehicle. And it's negative because it's approaching Calgary. The linear function c equals 25n plus 1,000 relates the cost c in dollars of a banquet, which depends on n, the number of people attending. Use a graphing calculator and the graphing window. X goes from 0 to 200 by 50s, and y goes from 0 to 600 by thousands to sketch the graph of the function. Draw the graph on the grid shown, labeling the axes. Okay, so let's get out a calculator. Okay, we've got a calculator. Turn it on. Let's clear that. So we're going to set the window 0 to 200 by 50s, and y min is 0 to 6,000 by 1,000s. And ideally, what you want to do is match your window to what you're going to see if you see a graph or if you're given a graph. We can't graph c equals, we have to graph y equals, so 25, and we can't use an n, so 25x plus 1,000, and then hit graph. So there's our graph. Draw the graph on the window. So we got a point here at 1,000, right? Because this is 1,000, 2, 3, 4, 5, and 6,000. And this is 0, 50, 100, 150, 200. So if we could get this point here, second calc value. So give me the x, give me the, value. So 6,000. Okay, so we've got 2 points on the graph here, and at 200 and 6,000, let's label this is number of guests. We don't need units because it's obviously a number. And this is cost, and we do need units. The cost is in dollars, right? Because who knows, it could be euros or something. And we're going to draw, oh wait, I'm going to do a straight line. So hang on, I'm going to do this right. Boom, straight line, nice. Live and learn. What is the slope of the line and what does it represent? Well, we can see that we're going up 5,000 when we're going over 200. Up 5,000 what? So that's a plus. So it's $5,000 per 200 guests. So it's $25 per guest. So that's the slope of the line. $25 per guest. And it represents the cost per guest. Right? And we can get that as a unit rate. What is the vertical intercept? The c-intercept. So it's 1,000. And what does it represent in this model? So 1,000. 1,000 what? $1,000. And it's the cost for 0 guests. So it's the fixed cost. You know, renting the hall, etc. Rent, hall, etc. Right? So nobody shows up. It's just the cost of renting the hall. And that's all we're asked to do here. So we're done with this. Next up will be the review. I will have a video on that showing, because I need a key for that, so we'll get all that done for you, and it's available if you want to review it.